Non-Dev Diary 25. So I took the liberty today and I figured out some things off camera, but I didn't do it off camera because I wanted to hide them from you or not show you them. Did it off camera because it took a little bit of tweaking / fiddling to do, and watching somebody get the error message 100 times isn't necessarily exciting to see. But we're going to go over it because I think every person here who watches this or watches this on YouTube would enjoy it. So what we did yesterday is what we made the metal fab class for the metal fab bench, and then we were trying to get it so we could lock attachments to it. Now these attachments weren't able to be locked before. So I have some stuff in here, some stuff in this code that is kind of useless. So we no longer need to worry about this stuff, but we're not going to remove it just yet. Alright. So, what we did today was we registered the lock attachments. Now, almost all the stuff in here is not needed besides this stuff down here. So usually I would do this for locking in place, but this is useful for locking attachments in place when you're doing functions inside of it, or essentially calling it in a function. But we want to make sure that each individual part can be locked, so what we did instead is we did this. So we made a class, and in the class action we designate the target object into different segments, right? So we have a bench, we have a grinder, vise, saw, and drill. Okay. Now, so this is everything we need, and then we needed these two things up here. All right. Now, what happens here is that mname equals lock, which is essentially, this could essentially be instead just say return and then brackets, and then you can put lock here. Oh! You could put lock here and do that. So the mname equal lock does kind of exactly that. Now I was prepping to use mlock as a variable so I can like switch out the names, but I decided to go against that. Okay, so what we need to do here is over here we have our action condition, and then we have it designating every single one of our pieces that can be attached, as well as the bench itself. So what I say is I go if not bench and drill or saw or vise or grinder return true, which allows you to lock the piece in place. It goes if it is the bench that you're looking at, return false, and I'll go over that in a minute. And then of course we return false if you don't meet any of these criteria. So and then on the override execute server, it gets the item base, the target IB equals the item base, and it gets the object, right? And then what it does is it locks it to the parent. So you know how like when you attach a hunting scope to a rifle, if you were to lock to parent, it would lock the hunting scope to the rifle. So it couldn't be taken off unless you unlocked it. I got the inspiration for this kind of from DayZ's recent edition in 1.11, where you could take a screwdriver, wrench, lug wrench, stuff like that, and lock down parts. And I thought that was really cool. I actually really like that idea. And then down here, I did the same exact thing, but because it inherits off the lock fab part action above, all I did is just change the return string, and then I made it unlock from the parent. So now when you look at a drill press that is there, you can unlock it. And then what we did over here is with we registered both the actions, the lock and action unlock, and then we registered the actions to lock is to the screwdriver and the unlock is to the crescent wrench. Obviously that might change in the future, but you know, right now that's what it is. And then what we did here is we defined our attachments, and then here I pretty much just put in a bunch of stuff, but we don't need that stuff anymore. So that's kind of what I did. Now over here I did is electric appliance, and the reason why I did that is because I want to make the metal fab bench require power. That way you can do recipes and other things like that on it. So let's go ahead and actually make this work how we want it to. So we're going to give it a energy manager. Okay, so the very bottom, outside of the damage system, we're going to give it an energy manager. And I kind of like to give it a put the energy manager at the bottom just so I can figure it out. Be right back. Sorry about that. Okay, so we want to make it so you can plug items into it. So let's go ahead and give this a shot. So we're just going to pack it up. Alright, so now we packed it up, we can boot it up, and of course I hope there's no errors. There shouldn't be any, but you never know. Alright, no errors. Okay, now we can go to our DayZ thing. We're going to switch to the metal workbench, make sure we're joining the right server, and we're just going to click play. Alright, so I'll show you guys the fun locking script I made, and then I'll show you how it works, and then we can see if we can plug in stuff to it. It should be pretty easy to do, but you never know. Okay. So, change it to whatever time. Alright, so let's say I have been busy and I have collected all of the pieces for the workbench. We have the metal chop saw, we have the vise, we have the drill, and then finally we have the bench grinder. All of these still have the testing names in them because we still technically are testing. Alright, so if you were to get a screwdriver and you were to walk up to, say, the workbench, you see how there is no option for the workbench? But if I look at the chop saw, now at the chop saw, you can see right here, if I get close enough, I can pull the chop saw on and off without any issue. So if I take the screwdriver and lock the chop saw in place, let's just hotkey that. Now there is a wrench on the chop saw and I cannot pull the chop saw off. No matter how hard I try, I cannot pick it up in my hands, nothing. Even if I had an action to remove it, you know, like some actions have where you can like pick up items in your hands, like planks or nails, you could not remove this until it was unlocked. And you can do this for the vise. So now I can't even interact with it at all. And you can do this for the drill press. And then finally, you can lock the bench grinder down as well. Now what's cool about this is that you actually have to look at each individual part and lock it in. You can't just ignore the parts and not be able to lock them up. Okay? Now, what you can do is, let's say you decided you don't want to be in the middle of the road. You are tired of being the middle of the road at butthead, right? What you can do is you can take another tool. Mind you, the tools might change on what locks it and what unlocks it, and you can unlock these tools. So for the chop saw, we can unlock it. As you can see, I made it take a little bit longer time. The times will change on how long it takes to lock down an item and how long it takes to lock an item. But now I can pop the drill press off. Now, I do have an issue where you see the lock and unlock when it's not attached to something. This is okay. Because if it's not attached to something, it won't lock to anything. So like, I'll show you in just a second. Yeah, Jingy, that's hilarious. You and your bad driving. Alright. So let's say I take my flat blade, and here is my vise. If I were to do the animation to lock it, it doesn't lock. I can take it in my hands. It's not going to cause any issues. And see, and then I unlock that, and now I can unlock the bench grinder. Okay, so bench grinder is unlocked, and now that everything's unlocked, I can take this into my hands and I can place it wherever I want. Obviously, I did not have the animation done properly for the bench, but I can go over here, and now that I have the workbench where I want it, I can put the pieces on there. And then I could lock them back down. And what's cool is that when even one thing is attached to this, you cannot pick it up. So like, you have this in your base, and you have any of these items on it, you technically cannot pick up any of these things, right? So that's kind of cool. Another thing to understand is we also did the tools. So we have a hammer, we have a hacksaw, we have pliers, right? So this all goes in the places it's supposed to go, and you can see the hacksaw there, the hammer there, and the pliers there. Now, I did mention that I might make it so the pliers can't float in the air. I will do that later on. That's just a simple hidden selection. It'll just hide that if it shows. Alright. Now the geometry is still a little bit messed up, so I have to look at that myself. But what's cool is the fire geometry for all these do work. All right, let's give this a shot with a generator and a power cord and see if we can plug it in. So we plug it into there, and then we can connect it. So there we go. The power generator is connected to here. Now, you don't see any cables because technically that's in the model. So like in the model here, I'm going to have to put some cables in. But yeah, it's pretty much how it's supposed to work. So what I'll do is I'll probably make a cable that goes to the chop saw, the power drill, and this, and I'll have like a little plug there. Should be too hard to make. Okay, so what we do here is we're going to essentially put a spark plug and a spark plug and some gas on it, and we'll see if it actually drains. There we go. Alright. So the way for us to test if this is actually doing this properly, we'll get a truck battery. We'll get some metal wire. And I believe we can go truck battery to here. Now, what is probably going to happen here is because the yeah, I don't think this is a auto on feature. Let's see here. spotlight. Yep. Okay. So it's going to be a very, very slow trickle down effect. It's not going to be very fast at all. So I don't think we'll actually see the truck battery get drained real quick. So what we're going to do is we're going to go back to our config and we're going to adjust the drain per second. We're going to adjust it to like 4. Okay, so we're going to go to 4 every 4 seconds. It's going to drain. This should give us a good idea of what it's going to, if it's going to drain power. Then we can start working on the other stuff. All right. So let's go ahead and boot it up. So how's everyone's day been? Good, I hope. Okay. There's the battery. There's the cable reel. Alright, so let's go to reposition. Place it here. And let's just take this into our hands. There we go. So plug this in here, plug it in there. And then what we're going to do is we're going to see how fast, if the battery on this drains at all. So I don't think this is going to. So what we can do is we can just add an action real quick, which is I think turn on is the action name. Yeah, action turn on while on ground. And what we're going to do is on our Metal Fab workbench, we're going to just essentially add a turn on action for it. We're going to do a turn off action too, just so we can turn it on and off kind of thing. Okay, so adding those two things should allow us to turn on our workbench and off the workbench. So let's go ahead and try and get this done with. Okay, packed successfully.
Yo, Andrew, do you want to play some Fortnite with me, Michael?
No, I'm streaming.
He said no.
Multiple declarations of set actions. Oh, did I already set an action inside my thing? Ah, I'm a silly man. Most times I put the set action at the very bottom of the thing. Um, so let's just move it down there. Alright. Now, once we get done with making sure that it powers up and stuff, what we're going to do is we're going to export the workbench and all of the models to scale into Blender, and then we're going to essentially make a power cord that connects the drill press, the chop saw, and the grinder all together, and then we'll have it come, all three cords come into like a major socket, and then that major socket will go down, and that's what will connect to the power cable. Sound good? Good, because that's what we're gonna do. Okay, let's boot it up. Also, don't be shy to give your feedback / ideas. If I don't like it, I'll let you know. Or if I think it's way too much work, I'll let you know. But most of the time, I enjoy new perspectives on things. Most times. Switch on. Let's double check some stuff. So we're just going to reconnect this. Okay, so it's switched on. This should be draining the truck battery. Let's look at our scripts real quick. No. Nothing yet. Be right back. Alright, back. Sorry about that. Alright, so let's go to vehicles. We'll go to, is it parts? Yeah, battery truck, right there. So this has a max storage of 1500. Yep, look at that. The battery is going down. You can see it. So this technically right now is a powered workbench. This is really cool. So let's switch it off. Yeah, nice. See how it took down the battery? Nice, very nice. And just so we can repeat this, let's get a battery charger. Connect the battery. Let's put the spark plug in here real quick. Charge up the battery. Oh, I forgot to switch that on. Alright, so we're going to charge up that battery real quick. There we go. Now it should charge up. There we go. Should charge it up. Sorry, folks, I've gone quiet. Mass was asking me some questions. Alright. So, now that we got those two things done, begin work off of that kind of stuff. So my question here is, how much power does a power generator make? And the answer is it maybe we have to look up inside the grep one. Notepad++. Alright, so it says here that the on init energy, so on work start, okay. So up here, it states that the fuel to energy ratio equal get comp, get energy max. Okay, so we know the energy max is 10,000. Okay, so if the energy max is 10,000, sorry, just pulling up a place to put this 10K, and then it states that the capacity divided by the capacity. Okay, so the capacity for this thing is 7,000. So divide by 7,000. So if we go 10,000 divided by 7,000, it's 1.42 energy a second. And it also states here that it uses 2.8 energy a second. So minus 0.28. So it creates 1.14 energy a second. So what does that mean for us? Honestly, I think the math was kind of useless. So so it was 1.428 a second energy produced minus 0.28 energy equal 1.1485 energy produced a second. So because it is energy is produced per second, then what we can gather from this is that this okay. So now what we're going to do is we're going to put this back down again, grab the metal wire, attach it, and we're going to switch this on. Okay, so what I kind of want to do is I want this to, because now we know how much energy per second a generator actually produces, what we want to do is we want to make it so that the max energy a truck battery has at spawn is 1500, right? So what we'll do is we'll do a calculator. We'll do 1500, and we're going to divide that by 1.4. Oops. 1.1485 and go to equal. So that is that is 1.485 energy a second. So that is 1,306.05 energy for an entire lifetime of a truck battery. So if we go to this and go divide by 60, which is minutes, that's 21 minutes of battery lifetime. So I think that's actually pretty cool. So if we make it consume 1 energy a second, it would be pretty cool. Let's go ahead and look at what the spotlight consumes per second. So spotlight, it consumes 14, and then what does the car charger do? So a car battery at this rate, 500 divided by 1.1485 divided by 60 only lasts for 7 minutes and 2.5 seconds at that rate. So that's actually not bad. I could have swore the charger was in the car area. Let's go to tools. We're looking for the battery charger right there. How much power does a battery charger consume? Charger. Alright, so a battery charger consumes... Oh man, that's nothing. That's horrible. That's really small. So, okay. Well, I think having our metal fab bench consume 1 energy a second is fair. So that means that a truck battery has 3 times the car battery. So if we go 500 seconds divided by 60, that equals 8.3 minutes times 3. So it's 25 minutes for a truck battery, and it's 8.3 minutes for a car battery. I think that's fair. And if you're using a generator, that is a 1.14 gain. So what we might do is we actually might make this 2. Instead of being that, we'll make it 2. Yeah, let's go like 8.5. So now, go 500 divided by 0.85. That is 588 seconds divided by 60. That's 9.8 minutes for a car battery times 3. That's half an hour for a truck battery. And what that means is that when someone uses, let's say, a spotlight, they could have a spotlight and maybe a car battery plugged into the same generator and the workbench. Because if the workbench uses more power than a power generator can produce, or it uses, let's say the bench uses 1 energy a second. So that would mean that only 0.1485 energy is left over for other things to be used. AKA meaning you couldn't run 2 things at once. So like if I turn this to nighttime, yeah, so if I go here, walk backward, unplug cable, alright, so plug the cable in here, plug the cable in here, and then if I go here and go to Spotlight, don't want that. Okay, so then what we're going to do is we're going to go to we're going to connect another cable here, and then we're going to connect it there. Okay, so now if we make it nighttime, hard to see. Let's give ourselves a little bit of a move. There we go. So as you can see here, I am not able to turn on the light at all, right? But if I go over here and turn off this, so there you go. So I think I accidentally unplugged the device. So let's try it again. So let's switch this on. And then if we go over here, now you gotta remember, this has an energy buffer inside of it. So what should happen is eventually this light should technically run out of energy. Or they're both fighting for the energy. Either way, you'll be able to have your workbench working and a work light and a car charger working as well. Alright. Alright. So, we have all that done. What we want to do now is we want to do some basic stuff, which is what I want to do is I want to put a auto shut off in there. We can give it a icon. All right. So we got all that done. I think that's pretty cool. Let's go ahead and make the power cord thing happen. So what we want to do here is we're going to extract those two. FPXs. All we want to do is just select the current selections. All right. So let's go ahead and export this too. Hello, viewer. I think this is Exalt. Alright. I don't want to export it as an MDA. That would suck. I want to do it as an FBX. This is the device. Honestly, we don't need to actually even export the device. I don't know why I am, so derpity derp. Derpity derp derp derpity derp. I feel like the Final Fantasy song for myself. Der 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 der. Okay, so what we're gonna do is we're gonna open up the magical blender because it's Blender. Have you ever seen Blender before? It's Blender. And then we're not gonna open up any files, and we're just going to import FBXs. So go to pictures. We're going to go to metal workbench, FBXs, and we're going to import all of them but the device because we really don't need to. So what I should do is I should technically import them one at a time. See how everything is coming in as a thing? It's not what we want to do. Okay. Alright, so let's go ahead and check out the thing real quick. So, object builder, we're going to open up the metal fab workbench. Alright, so yeah. I wonder, could I just go extract proxy? Yep. I can just do this. we can just go at file export like this, export all, close it because we don't want to save that, and then we can just delete all this. And then import FBX pictures, FBX is complete. Perfect. So there we go. There's our workbench. So what we're going to want to do now is make another thing. So we're going to change the view down to 0.00, and as we can see here, it looks like this goes down below. So what I want to do is I want to add a cube. Alright, so we have made a little hexagon thing. we're going to go into this mode. Alright. So, solve vertices. There we go. And then what we can do is we can go this route. Now before we go too far, what I want to do is new backface calling. Awesome. So what we can do is we can now go further, kind of make a, interesting kind of things. Honestly, we can go all the way to here. Maybe a little bit, maybe right here. E, extrude, rotate, kind of go there. E, extrude again. Extrude again. Alright, then we're going to push E, extrude over here. We're going to rotate this a little bit and go E, rotate a bit more, go back a little bit, E, Alright, so we got the cord into the power drill. Actually, you know what? What I could do is could make the cord go here, extrude it, rotate. Yeah, so I can go have the wires all coming out the bottom of the thing. Well, folks, I've been at this for an hour and